All right, I'm going to repeat some of what I said before the recording started, and that was why I opted to move today's challenges into Docker. And again, the reason is I wanted to avoid any potential install conflicts that happens from having two different package managers on the same system. So the challenges were written to utilize apt, and Mac OS users, at least with our curriculum, are instructed to install everything through Brew. And so having both Brew and apt on your system at the same time, it's not the end of the world, but it could potentially lead to conflicts if you're installing something like Postgres with one over the other. With that said, we are going to run through what we have in today's lesson plan. So let me share my screen. It's going to be basically a few more CLI commands. We're going to also do learn some CLI commands to run Docker, and then I'll demo Docker and some of the challenge. Just a warning, Docker will want you to, very true, good point, Yams. So we're going to have to deal with that. We'll deal with that after the lecture. Shouldn't be a big deal. Cool. So let me share my screen. We are going to switch back to this. Today we are going over CLI and basically, oh, and we were also going to be going over permissions, use permissions, groups, etc. And that's the challenge, actually. That's going to be inside of a Linux image being run through Docker. I wanted to ask you guys one more thing, actually, before we started. How familiar are all of you with GitHub? I just kind of assumed, but I need to stop making so many assumptions, that you're all very comfortable with running Git CLI commands and pushing to a repository. No?
It's new to me.
Okay.
We did a lot of it in Whiskey, and we went over pull requests and code review. That was like the extent of what we went through.
Okay.
Yeah, actually Friday, actually correct me, those of us from Whiskey. I want to say Adam mentioned Friday, I think, going over additional Git commands beyond what we have used.
Okay.
Yeah, it was, I think GitHub Actions to continuously integrate.
Yeah, was that Friday or was it Thursday that I'm thinking of? I remember seeing it right as I left for this class. So it was added to the calendar. Actually, I could just go back.
All right, then I guess what we'll do is after the demo and when I open up the breakout rooms, I'll stay in the main room, and anyone can join me in the main room to go over. First, we'll go over, I guess, Git, just so everybody is caught up on what we at least need to do to be able to pull repositories down and push solutions. And then we'll run through Docker install issues if anybody runs into them. Sound like a plan? Cool. All right, so our learning objectives. We are going to learn some CLI commands, command line interface commands, and some of this is going to involve creating users, creating groups, changing permissions for files, and doing this in a Dockerized container. So the first part of our lesson, I'm just going to pull this up. Okay, cool. I am still able to see my terminal. We want to run through some of these commands. Let's do a quick recap. I know a lot of you already know a lot of these, but this should only take a sec. Troy, can you tell me what PWD stands for?
DWD or PWD. Yeah, that was our present working directory.
Yes, exactly. Awesome. Natalia, can you tell me what LS stands for?
This file
Yeah.
in a current directory.
Yes, exactly. All right. CD, somebody, anyone, shout it out.
Change directory.
Right on. Absolute versus relative paths, which I did ask yesterday, but let's have it again.
Relative, use a period, relative, search for that file name in whatever current directory you're in. And then absolute won't have the period, and you will like have to put in the full path coming from the root.
Right on. Exactly. Awesome. And the rest here we have mkdir. What is that?
Make
It's
directory.
creating a directory,
Right on. What is touch?
creating a file.
Make a file.
Cool. CP.
Copper.
Is it a copy?
Yep.
Copying a file to another directory.
Yep. MV.
Move,
Yep. And RM.
remove.
Right on. Awesome. Now, how many of you all are familiar with Vim?
Only
have it,
enough.
We didn't utilize it really.
Haven't used it.
Only enough to get in and know how to save and exit. And use
It's
lazy
not
Vim.
even.
Use lazy Vim. That's it.
Did you all end up using Nano instead?
He just
Neither.
Adam went over like a quick overview of like, yeah, how to like get in there and quick edit and then write and quit. But that was the extent of our bin. Then we just moved straight into VS Code.
Okay. Yeah, it's definitely a handy tool to have because as awesome as it is to be able to actually, yes, Tristan?
I was just gonna ask, I've used a little bit of Nano. Is there like a big difference between Vim and Nano?
I think Nano has more features, so the folks that use Nano tend to prefer it over Vim. Vim is a very default vanilla kind of text editor, so I don't think I really recall anyone being passionate about Vim, but it's very commonly available to use. Use cases for either Vim or Nano is primarily going to be when you're in a situation where you don't have any control over the environment, right? So like when you're SSHing onto a host, when you're execing into a Docker container, you may not be able to install the code editor, text editor of your choice. You're going to have to use whatever's available. Yes, VS Code is awesome, and it's got like a lot of really cool extensions and features, and I like VS Code. I think a lot of you guys do too. You're not always going to have it available. We'll see that when we run through today's challenges, and I'll demo that as well inside of a container. So we're going to have to know how to navigate Vim, and it's fairly straightforward. I have a README in here. I could type code to open up the README in VS Code, but of course I won't always have that option. Like let's pretend I was working inside of iTerm, and I was on a host. That code command will fail for me. This is where things like Vim come into play. So if I say VI as opposed to code, now I'm inside a text editor. There are really only a few commands you have to memorize with Vim. One is I for insert. Once you hit I, then you're free to start doing whatever. So let's say I'm going to add a new entry, whatever this is. I hit escape to stop editing, and now I could navigate like normal, and I could press my keys to call other commands like W or Q. Sorry, you have to hit colon first for passing in commands. So one thing you have to remember is I for insert. Another thing you're going to want to remember is colon to call a command. Notice how my cursor moved down here. W is to write. Exclamation point or bang is to force it. Q is to quit. That's pretty much all you'll need to know. Like you can get away with just knowing those three things. So I'm going to quit without saving because I don't want to save that. And I'm out of here. And one more cool thing about Vim is it will warn you about stuff. So I think if I were to try to add whatever, and if I were to try to quit, it's telling me that I have not written since I've made changes. So I could either continue or hit escape or just quit with a bang and force my way out of there. Any questions on that? It looks like the README actually mentions WQ, which I don't know, you could argue that's a new command or it's the same command. You're basically writing write and quit at the same time. So it's going to save and exit you out. All right, other commands, echo. I think you've probably used echo in a few, I don't know. I honestly don't have too many use cases for echo, but it's there if you need it. It basically echoes whatever you pass in. Oh, look at that. This seems useless, but you will see the utility in a moment. I'm excited. Okay. All right, sort. Sort will sort lines of a given file by alphabetical order. Let's see this in action. So file.txt. Actually, for the sake of this exercise, I'm going to use Vim. I'm also going to zoom in a bit because my font is probably really small. Let's make a new file called file.txt. Let's say apples, bananas. Oh, this is already in order though. We want this to be out of order. So like, let's say figs and I don't know, donuts. I know it's not a fruit, but whatever. We're gonna write, we're gonna quit. And now we're gonna see if this this sort will work on our file. Oh, look at that. Magic. All right, next we have find, which will search a directory recursively for a matching file or folder name. Let me cd up here, or yeah, let's do that. And let's see if we could find file. It does not find file. So let me go back to this directory. I wonder if it searches upwards. So if I make a new folder, or I just go into this one, and I try find again, still doesn't find it. It says it searches a directory recursively for. I was thinking that would mean that it allows for searching up and down different folders, but I guess not. So let's go back up one directory and let's try find one more time. Ooh, does it really want me to be specific? You can tell I don't use this command very much. It wanted the entire file name for some reason. It doesn't let me complete. That's why we have grep. Grep is a little more friendly, but it lets you find. I think you could pass in incomplete strings and it should find it. It looks like it's hanging here, maybe because there's too much to search for. Let's use grep in another context. The use case I primarily have for grep is to look through my command history. So if I were to type history and grep, let's say, I don't know, find. It's going to show all the times that I tried to find something in my last session or my current session. I think it does go beyond your current session, depending on your configuration. So if I were to type, I don't know, what's something that let's see what kind of commands I've written. It's not finding anything, so maybe it is in the context of the session of your terminal. So this terminal has only been open for like, I don't know, an hour, and I have apparently not used any git commands in this terminal, so it's not returning anything. grep is really useful in a Linux environment, or let's say a Ruby environment even. You could use grep to do other cool things like looking through the available methods of a class, for example. The way you call it is gonna slightly vary based on the context, but it's a very powerful tool. Interrupts. When something is hanging, you have two choices. And I shouldn't even say when it's hanging because you could use this whether or not something is hanging. Oh, sorry, I'm looking at the message. What are the numbers next to find file? Oh, this is your input history, I guess. So like the order at which these commands were called. I think if I just type history by itself, it's going to show me like the last, I don't know, 10, 15 entries or so. There's somewhere in your config that you could set these. You could also change the limit to how many of these entries are stored in memory. I do not remember off the top of my head where to find that. If I remember, I'll try to Google it later. Yep. So interrupts, we are able to use these interrupts at any time, but you'll primarily want to be using them if something is hanging. Control C will, well, I don't want to use it now because it's probably going to close this terminal, but let me do it anyway, or no. Control D will close the terminal, whereas the Control C did not. And also was giving me this, which I'm going to close. And clear this screen. So Control D, it's similar to the above, but a little more powerful. This sends an interrupt signal to the operating system to quit the currently running shell. So if you're in a situation where like nothing is working, Control C is not working, escape is not working, use Control D. Okay, keyboard shortcuts, we know, well, not all of us know this, so it's definitely useful to remember if you don't use it yet, but you can scroll through your command history with up and down. You can also recursively search your commands. So earlier I used grep to find some commands, but I could also, this is a new terminal, so it's not going to find it, but I could also use Control R. And if I do Control R, it will autocomplete a result above based on what I'm typing in. So this goes further beyond your current terminal instance. So now it's finding the last time I used M in a command was when I pushed changes to a main branch. And this is a super handy command, especially if you're, let's say, trying to learn a new command that you don't use and you just cannot remember it for whatever reason. Just start playing around with different stuff. Once you type in a letter, you could even like start scrolling from there. So Control R for recursive search, super useful. And Tab to autocomplete. If you're not using this already, try to get in the habit of it because it is super cool. If I go up one directory and I type, let's say CD bash scripting, I could just hit Tab to autocomplete and I don't have to spend precious seconds typing out the rest of that. Really especially useful if you're dealing with long file names or strings that are just a pain in the ass to type. So tab for autocomplete. Okay. Sudo, I believe all of you are familiar with already, right? Okay, sudo stands for super do or yeah, super user do. In a Linux environment, it may not be available. It depends on the distribution you're using. If it's not available, it's likely that SU is available, which is just super user. Clear clears the screen. I prefer Command K. It's just a little faster. File navigation. Nice to know, but less relevant if you have VS Code. I honestly don't really. Oh, I do use some of this. Tail is super useful when you are reading logs. You could even pass in a command parameter to tail to have it update live. So let's say I am on a host troubleshooting, I don't know, response time or something. Tail will just give me the last 50 or so lines of a file. But maybe the error hasn't hit yet. Maybe I'm waiting for a cron expression to complete and a task to set off a chain event and then turn up whatever event I'm looking for. Having tail and passing in F will have it go live. So tail F live. You could also then pass in the number of lines you want. I wish I had a good example of this because it's really cool to see in action. But yes, tail is a super useful command. It will just let you continuously update what you're seeing in your terminal based on what logs are being fed to that log file. That's definitely a good command. I don't think I've used less before. It lets you see the contents of a file, navigate like so. So let's go back to my, is this the folder with my file name? Wherever I made that file. All right, I might have been curriculum. Maybe I deleted it, I don't know. I'll just make a new file using Vim called try less.txt. So apparently this lets you see the contents of a file and navigate like so. So let's just make a bunch of lines and see what happens. Oops. See how I type colon, but I'm still an insert. I got to hit escape first before I can actually pass in other key commands. So let's use less with this file. Okay, that's interesting. It's there, give it a shot. You might find that it is handy when you get around to parsing through long log files and whatnot. Man, what does this do? Everything you have seen up till now are essential navigation commands, but there are many more. Man means manual, and it's a quick way to see what an unknown command does. Interesting. So let's see. Ah, look at that. It's going to give us some additional context on less. Less is a program similar to more, but which allows backwards movement in the file as well as forward movement. I want to see what more is then. It didn't like that, I guess. That is man, apparently. You could use it. It sounds like it's really handy. I might have to start using this myself more often. All right, change mod for changing permissions. Have you guys had to use change mod yet? CH mod. You will have to use it this week, not only for today's exercises, but this Saturday, Chandra's going to be going over SSHing with all of you guys. And part of that means having to grab a PEM key and run change mod on it to change the ownership permission of it. You'll see when you get there on Saturday. And today we're going to use this in our Linux exercise to see how it's part of the exercise. We create users, we create groups, and then we change some ownership and permissions on a file just to demonstrate how you're able to do that and what that does. So in this instance, chmod is getting passed in a plus, and that is the plus operator is telling us that we want to add this permission. X as a permission stands for execute. So chmod plus X allows us to make a file executable. Ch minus X will take away that permission. All right, operators. You should be familiar with some of these. You might have used them in Postgres searches and queries. Star is a wildcard that will basically look for any number of anything following everything that precedes it. The forward and reverse carets allow for input redirection. I don't use it a lot myself. Pipe is an operator that means or, and then we have and ampersand, which I believe you should already know. That you've probably used it in a few of your algorithm challenges already. Let's see. Any questions about CLI commands? Cool. All right, let's move on to user groups and permissions. Okay, this talks a lot about stuff that I think might be easier to just see live, and it's talking about using apt. So let me actually spin up Docker now and run some of these commands instead of just talking through them. I want to go to, yes, this is where I want to be. By the way, this J, it's an alias for a command called auto jump. It's a pretty cool command. I might have told a few of this about it yesterday already, but it basically caches all of the locations you've been going to as you navigate your computer. Yams, yes.
Is that a pre-built alias or do we have to set that up?
It is definitely not pre-built. It'd be cool if it was, but no, you have to set it up. And it's been a long time since I set mine up, but I do think it's not that it's hard. It is easy, but I remember running into a few issues and that might happen again. I think after we get through all of the Docker setup stuff today, anyone that's interested, we could run through a auto jump install session as well.
And you said it was short for auto jump, all one word?
Yep. Let's see. It can be installed using brew. So brew install auto jump. It basically caches the places that you've been to, counting how many times you've been to them. So if you've been to a location recently or frequently, then J will magically take you there. And yeah, this is auto jump. I'll just copy paste this into our Slack. Cool. All right. I was going to spin up a Docker container. Okay, let me give you all a quick breakdown of Docker. And I might actually want to pull up my incomplete slide deck just to give me a bit of something to follow here. Oh, I love this image. I'm not teaching SSH to you guys this cohort, unfortunately. So I'm just going to share this image with you now. This is what you will be going over with Chandra on Saturday. Fun stuff. SSHing is really cool. But what we want right now is to talk about Docker. So it's a containerization platform. It allows for strict environment and version control, as well as simplifying the process of building, shipping, and running applications. So a Docker, let's say the Docker desktop, or I shouldn't even say that. Docker consists of these various layers or entities, right? And this can be confusing at first, but I promise eventually it'll feel very simple. You won't have to worry about volumes so much. Volumes are kind of self-explanatory. That's where data is stored. So it's just storage. But images and containers are primarily what you're going to be running commands on. An image is what is created from a Docker file. You can think of it as the output of the Docker file being like, let's say, a recipe of some sort, right? Once you have an image, it's just kind of like a static thing. It's not doing anything. You have to run a container out of that image, and the container is the dynamic thing that you're actually interacting with. Does that make sense? I guess it'll make more sense when you're seeing it live. But that's what images and containers are. Let's look at it in Docker Desktop, actually. So this is the Docker Desktop interface. You'll see containers, images, and volumes at the very top of your navigation here. Containers, this is telling me that I currently have a container running. So I must have forgotten to exit out of this earlier today. One cool thing about Docker Desktop is you can see inside of Docker Desktop what is happening in your container. Apparently, I see some stuff that I was doing earlier, which was adding a user. Yeah. You could, if you could do it this way, but I would personally encourage all of you to exec into a container when you need to. So just let me know if I'm just jumping around way too much from different parts of Docker. But when I say exec, it's kind of like, let's say execution, right? So if I were to write Docker PS, this is going to tell me what containers I have running. I see that I have a container called bash container with a container ID, which is just the hash. I'm going to write Docker exec, and I'm going to pass in a flag IT for interactive terminal. That's how I like to remember it. And then I'm going to just pass in the hash, the ID, the container ID. And then I think I'm going to have to say something like this. Nope. Maybe bash.
Yeah, bash.
Thanks, Phil. So the last thing that you're passing in is basically a command. Like it's kind of like, I guess, an entry point command. It really boils down to how you write your Docker file. And well, I guess not really so much how you build it, because how you build it, how it's built is going to depend on the Docker file. So yeah, what you type in here to exec, it's going to be based on what you write in the Docker file. In our current Docker file, we have, which one is this? It might be this one, but it might be the other one. In our current Docker file, we have, oh shoot, right, these aren't the challenges. Sorry, give me 1 sec. Let me find the challenges. Oh, here's something that I like to do. Whenever I get lost in my very poorly organized folders, I like to just type pwd. Oh, here's the bash container that was running. I'm going to exit out of this. I'm going to exit out again. I'm going to type pwd to give me a present working directory. And then I'm going to command click to pull up this location in my VS Code. And from there, I could finally click on the Docker file that I was looking for, so I could show you guys that this Docker file is saying from this location, so the official Docker hub, I want to pull this image of Ubuntu, which is using Ubuntu version 22.04, run these commands. It's going to run debian underscore front end equals non-interactive. So it's spinning up a non-interactive session so that it could run these commands. It runs an apt-get update. It then runs an apt-get install so that it sets up Python. And then it removes some unnecessary installation files. And from there, we have an instance of Ubuntu running inside of a container. Any questions on that? Cool. So now if we go back to
Sorry, is this, so this here, is this part of an image or this is before that part?
This is before the part.
Okay,
The image itself gets built from a Docker file, and I'm sorry if it's a little confusing because I said I called this an image also, but that is what it is. You're pulling an image, an official image from somewhere, right? And then you're running some additional commands to create your own local image, an image of that image. And from your local image, you can run a container. So I exited out of the container already, so I can't run that exec command. Or I can run it, but the way that I wrote this this image is I wrote for it to self-destruct. This is a shell script. Yes, Saul.
Yeah, sorry to interrupt. I just had a quick question. You just did the Docker exec IT.
Mhm.
I didn't really catch what that one was doing.
Okay, yeah, sure. So yeah, I know I'm jumping around a bit, but I wanted to show how you could go inside the container a different way from just doing it inside of the GUI. You could use the GUI to start, but it's not going to help you memorize these commands. So I did already exit out of this container, so it's gone now. So let's focus on execing. In order to exec it, I'm going to have the container running. And I'll explain in a bit afterwards why it's no longer running and why the container is completely gone. But because it's gone, I'm going to have to run my build command again because I don't think the image exists either. So if I write a Docker image PS, or sorry, ls, yep, the latest Docker image I have is from a few days ago. So the one I created today is gone. It has disappeared from existence. So let me rebuild this image and rerun the container so that I could show you how to exec into it. I showed you the Docker file, but I now want to show you a shell script. This shell script is basically a simple 3-line script. It runs the Docker build command. This is the command that you will use to build from a Docker file. So here we're running Docker build, we're passing T for tag, and we're tagging it the name of bash container. And then we're saying search in this present working directory for the Docker file. Next, we're going to run interactively this bash container. And RM says remove once this container stops running. So we're passing the name bash container in, and that's the name that we're giving the container. And yeah, remove upon exit. Also, I want to remove the image upon exit. So after I finish running this container and I exit out, it's going to essentially delete itself. And that's why I have to rebuild the image now. So if I go into, yeah, let's take in this directory and let's say ./start sh. This is how I'm going to start my start shell script. If I call this bash script, it's going to run these 3 commands. So now we see the build stage and it runs. And now I am back inside of root. If I exit out, it's going to delete itself again. So let me show you one more time how to use exec from a different terminal. So if I do Docker PS, it's going to show me the images, sorry, the containers that I have. This container is using this image. And all I need is the container ID. I'm going to write Docker exec -it, pass in my container ID, and then pass in a command. The command I want to pass in is bash. I want it to load up a bash environment for me. So I do that, and I am now inside of my Docker container. If I hit ls, I see files that are not on my local machine. They technically are in my local machine, but they exist inside of a bubble inside of my local machine. If you recall from yesterday's slides, I was talking about, there might be we talked about the different layers of architecture, of Unix architecture. Docker exists as a layer inside of application programs. And you can imagine that Docker is basically just a platform and application that's running more code. And from that code that it's running, it's creating a little bubble, like a little environment that is isolated from everything else. So this file system is only available inside this little bubble, and I have no visibility on the files that exist out of this. Does that make sense? There are ways to create connections between your local machine and a Docker container that you run inside of it, but we are not going to cover that today. And that's essentially done through port mapping. But this is, in a nutshell, how you, yes, exactly. It's very much like that. Though I do think WSL inside Windows is much more complex. It's got to load up a bunch of other magical things, processes to run in the background, but very much like that. Let's see, any more questions about Docker?
You used image. So is there any correlation to like a VM? I'm looking at those files there, and it's not the whole operating system inside of this thing. What's the differences between a Docker image and containerized application and what it draws from the host?
That's a very good question. I will do my best to answer this, but I think I'm definitely going to be missing some parts to it. So these images that are distributed as official images, they are created in a way that allows you to, yes, like you say, this isn't like a full-on Ubuntu operating system because it's going to lack a lot of things that an operating system needs, right? Like an operating system is going to need a way to communicate with the kernel so that it could communicate with the hardware. These things, I think, inside of an image are, I guess, simulated for lack of a better word. So there are, yeah, honestly, the best way I can explain it is by saying, by design, an image is like a very compact version of software or application that is built to work inside of Docker. Does that make sense?
I think so.
Let's take a look at what might be running in the background. I think we definitely have apt. Let's do an apt list. We could see like these are the different packages, I think, that have already been installed. You can pass different commands in the Docker file, right? Like I commented this out, but there are commands that will allow us to limit what gets installed during the setup. We could also, as we see in this code block, give more specific commands, like we're telling it to run apt-get update so that it can download some packages. And then we're telling it to install Python. So if I were to actually type Python 3 in here, it opens up a Python terminal. If I wanted to exit out of this, I believe it's Control D for Python. If I wanted to type node, I'm not going to be able to because node's not installed, but I can install node. So apt install node, it's probably not going to let me do this right off the bat, but I can do apt update. It's now going to grab a bunch of packages that I could then install. And now if I do apt install node, or is it Node.js? Yeah, Node.js. Now install its node. I say yes. It's doing its thing. And now I can load a Node.js environment. Neat, right?
In the container.
Yes, I am inside of the container. And yes, Donnie, apt is like Brew that you all installed. They are both package managers. But because they're different package managers, they have slightly different commands. And that was why, that brings us back to the start of this, which is why I had to throw Docker at all of you so soon. So I just didn't want you all you Mac users to have to install apt on your local machine because you already use Brew.
But it's essentially a virtual machine just without a GUI or anything. It's like you're just running in there to run through the shell.
Exactly, yeah. For all intents and purposes, yes. So that's Docker container in a nutshell. It's there's all sorts of cool stuff that you can do with it. It's super clean. If we go back to my shell script, we have these flags that allow us to basically just clean up real easily, right? Like it was asking me earlier if I cared about how much space it was going to use up. I don't care because as soon as I exit out, it's going to disappear. It's no longer going to take up any hard drive space. So that is the magic of Docker.
Hey, Julius, I just had a quick question.
Mhm.
Yeah, I'm not sure if we're supposed to like know this already, and maybe some people here do, but I'm like very, very lost. So I just want to know if like we're gonna run deeper into this, or if it's something that I gotta like catch up on.
Yeah, you'll definitely have a lot of time to catch up on it because yeah, in your own daytime cohort, you haven't gone through it yet. Normally, normally students struggle with Docker. I struggled with Docker when I was first introduced to it. It's totally normal. It's a lot to throw at you. I am so sorry for assuming that you all had some experience and doing it so soon, but hey, here we are.
For the weekend group, what do you anticipate the Docker usage to be? And do you see it in like the capstone project?
Oh, it's definitely going to be in the Capstone project. Yeah, it's definitely going to be a big part of DevOps. Yes, Yams.
So bigger picture is that since we all get access to Dockers, when we
Sorry,
pull,
here's somebody.
yeah, sorry. When we pull images now instead of repos to our local machine, it goes into the Docker desktops. Is that kind of how this will go?
And I remember I
When you
had
pull
history
images,
reports and I was going through and I was like,
Yeah, when we
this
pull these
looks
Docker
bad.
images, we'll be working
70%,
into our
I still
desktops
has
or Docker
48
desktops.
processes
Instead, is that
and
how this will go?
dittos.
will you be working inside of Docker Desktop? Docker Desktop is basically a convenience tool that allows you to visualize what's happening through a GUI. You can use it, you don't need to. When you install Docker Desktop, it also installs Docker command line. So everything that I've been doing, I can just run everything from my terminal. And that is really the way that we would encourage you to approach Docker, because that's how you're going to get comfortable with these commands. I would say use Docker Desktop as a supplemental tool. Use it as a way to guide you when you're getting lost, because it is pretty cool to be able to hop into a GUI and see straight up the terminal that you would otherwise have to exec into. And you have access to some, I guess, very basic logs, some stats. Well, it's not spinning right now, so it's not going to show anything, but does that answer your question? or into your Docker desktop, it's going to go into your local machine. The Docker desktop is really just an interface. If you're talking about like your Docker Hub account, because you could create a Docker Hub account and then you could push images to that. Yeah, that's something that you can do. It's not something that you have to do. When it comes time to get into deployment and deploy something that you've built, Docker Hub is probably going to be like the most available, accessible thing to use, but you could push anywhere. I believe GitHub even has storage for you to push containers into now, right? Phil or Chad, correct me if
I haven't tried it, but I think so. I'm pretty sure that you can in your GitHub Actions workflow set up or like link your containers.
Yeah. Does that answer your question, Yams? Yeah, I want to say it goes into your local machine because when you run commands like Docker image list or Docker ES to see what containers you have, this is all stored on your local machine. The Docker desktop is really just a way to visualize where those things are. Thanks, Cassandra. Where does it say that? The Zoom title. Is it because we're using the same room as last? Probably, yes, probably because of that. I'll figure
Yeah,
out.
it would be. Yeah, I wouldn't worry about it right now.
I appreciate it though. I did not notice that. Okay. How is everybody feeling? Because I feel like I just threw a lot at you.
So this was all just so that we don't have apt and brew on our for Mac users.
Yeah, but you're also going to need to learn Docker eventually, right? It's going to be a big part of the curriculum.
Okay. Yeah, I'm looking at the curriculum right now and I didn't see it, so I didn't know how to like go back over things.
Yeah. Yeah, that's true. And again, I apologize for not having the entire curriculum up. I'm going to do my best to get that up as soon as possible, but you'll see as we go through the curriculum, just all the various use cases for Docker. In the evening and weekend program, I think one of the reasons that Chad wrote it in a way that Docker is used in pretty much once it's introduced in the evening, weekend full stack, it's used in like every project from then onwards. Maybe part of his thinking was it was to get the students more familiar with Docker and comfortable with it, which might be necessary because it does kind of take a while to get used to. It's a lot of different concepts to throw at you. It's a lot more commands to try and remember, but it's a big part of deploying and automating deployments that you're going to have to deal with for the latter half of the curriculum.
Julius, this week, is there from a code platoon's perspective, can someone walk through sort of objectives and milestones that we're going to be hitting and where these technologies? So I kind of want to set up a snowball, like, okay, we talked about Git yesterday, so I want to practice my Git every day now. We're talking about Docker, so I want to make sure, and set up this rolling snowball. And I think it would just help to run through the curriculum at some point from an overview perspective with you guys. If that's a breakout, just let me know and I'll.
Sure. I think it would benefit everybody in the class. So let's just do that right now. Let's just run through last curriculum's repository. So we could just talk through what to expect, what to come. So we would start off with Linux. And this is essentially what we're covering. This is still the same. It's the first week. We're covering user groups, bash scripting, intro to SSH. First week is virtually the same. I've just been cleaning up the formatting. From here, and you whiskey folks might be interested in here, from like weeks 2 through weeks 4, we pull a lot of the content from the full stack curriculum. It's like a crash course on what you guys learn, because we want to catch up students who did not take the full stack program, or at least try to catch them up as much as possible to where alumni are, right? So since you have your personal projects and you've probably done a lot of these challenges already, this is why I encourage you to prioritize your personal projects from weeks 2 through weeks 4. For everybody else, we're going to be learning the fundamentals of programming. So we're going to learn what object-oriented programming is at a foundational level. We're going to learn algorithms. We're going to learn Python, JavaScript. The basic beat is we go through a lesson, you're going to have challenges, and this is where I encourage you to use your Git commands to fork and clone these challenges to your local machine. Use your command line interface commands to navigate through that file structure. Use that to, yes, you could use your text editor to run through the actual algorithm and stuff. Like, you really don't need you to use Vim to write code. You can if you want the extra challenge, but these are some of the things you could do to like become very accustomed with that sort of stuff, right? So we're going to go over Python, and we're going to go over JavaScript, and then we're going to go over how to build a full stack application using those two things, right? And we use those languages because we introduce frameworks in the second half of the full stack curriculum. So once you learn how to build a full stack application from scratch, we go through it again, but with frameworks. We use Django for the back end. We use React for the front end. And Django is a Python-based framework, whereas React is a JavaScript-based framework. That's why we teach you, that's why we choose these languages to teach you. Once you know how to build a full stack application, that's your development part of DevOps, right? Then you can focus on the automation of that. We have to containerize the application in order to automate the deployment of it, to automate the building of it. So we're gonna, from the full stack portion, we're gonna switch over to AWS, where we have to teach a lot more foundational things, right? Because now we have to teach cloud services, because that's the second half of deployment. You can't deploy an application if you don't have anywhere to deploy it to, right? So we have to understand how to navigate the AWS interface. We have to understand what the different components of AWS is. I don't think my sign-in is working. So I should not have pulled that up. I'll show you guys, I'll have my sign-in taken care of by the end of the week or next week, and I'll show you guys some AWS. But let's continue on this path, right? We got to teach you things like EC2 and what routes are, how to set up various things inside of AWS so that you can navigate that very comfortably. This is why we spend like over a month in AWS. From there, we could take what we learn in AWS, which is like setting up your EC2 instances, both through the GUI and then through the command line. We learn how to automate this through Terraform. So now you're just writing simple Terraform code that will magically create EC2 instances, routes, permissions, load balancing, all the things your application needs for you. And with a Terraform command, you spin all of that up, and then with another single Terraform command, you take all of that down. It's pretty cool. From there, we'll teach you Ansible playbooks, which allows you just another level of fine tuning to the automation process. Right now, this is, by the way, let's refer to a DevOps life cycle diagram. So we kind of contextualize this a bit more. So we've talked about the development part, learning the fundamentals of software engineering. We talked about building that and then testing it and releasing. And now that we've learned cloud services, we can deploy to it. We fine-tune that a bit by teaching you more advanced ways of doing that at an automated level, which is where we introduce Terraform and Ansible playbooks. And then we teach you how to add some monitoring. So we're back in AWS learning CloudWatch. We're learning how to navigate CloudWatch logs. We're learning how to add additional monitoring services through external platforms like Datadog and Splunk, tools that are very commonly used in enterprise setting. And then from there, we finally move over into Docker and Kubernetes, where we teach you how to scale even higher. Now that you know how to automate a deployment, we're teaching you how to automate a deployment at scale. The power of Kubernetes is in how it can handle load balancing for your automated deployments. So now, instead of having to manually write configurations for how many instances you may want to have, you have this platform, this orchestration platform that is capable of doing all the necessary logic to know when it's necessary to spin up a new pod based on the amount of traffic coming in. Does that make sense? Is that giving you a clearer picture as to what all of this, how all this is going to tie up at the end?
Yeah, it is. Is Terraform our CI/CD? I was just trying to Google. What is our CI/CD pipeline going to be?
Yeah, when I think about CI/CD, continuous integration, continuous development, yes, I do. I guess I would include Terraform in that. I think it's easiest to think about conceptually as being the automated deployment part, right? So that's going to be like GitHub Actions, because the GitHub Actions configuration is what lists out the steps. It says, start here with these files, build based on this configuration, then deploy to this location. Here are all the parameters you need to execute all of that, right? Terraform allows us to set up the architecture necessary for that. So it sets up the instances where these things are going to live. It sets up the permissions for the users that are going to be accessing it. It sets up, a lot of the infrastructure that's needed to navigate these different components of your application.
The only element missing is, when does the capstone project, or what is the creation side to it for us?
Sure. So I'll say this, the capstone project, as it has been, is putting together everything you've learned in the curriculum to deploy through DevOps practices an existing application that has been built by one of the former classes, students. What would be really cool for this cohort, and I think it's very doable, is because we're going to be breaking you up into teams, even if you aren't a Whiskey student, you'll be on a team with Whiskey students. So I think it'd be really cool to see all of you deploy the applications that you build through these processes using Terraform, using Kubernetes. And so that's the goal. Chad, do you have anything to add to that?
No, I was just kind of responding to what Donnie was saying in chat. This is more of just for you guys to kind of get an exposure. Definitely don't feel like you need to understand all of this, but you'll start seeing all this stuff over and over and over again. And by the end of this class, you'll be able to teach your siblings about Docker. Seriously. So it's not something to stress about right now. It's just more like, take it all in. This is really cool stuff. Like Terraform literally makes you build an entire network that you can totally customize and then just spin it up and spin it down with 2 commands. And you'll be doing that. And it won't be really that intimidating. Just kind of take it in and just be exposed to this information rather than trying to learn everything and like jot it all down. I guess that's my big point.
Yeah, thanks, Chad. I do appreciate that. I think that's a very good thing to call out. It's this isn't something that you're going to be able to like really absorb and master in just an afternoon, right? Yeah, so that's a very good point, Chad. It's definitely exposure.
And Julius is going to teach you guys like all of this stuff over time. It's beautiful. It's almost like a symphony when all this stuff comes together. It really is. You just kind of kick back and just enjoy the ride.
Do you play in a symphony?
I wish.
It doesn't always come together. At the last dress rehearsal, you throw everything together, then you have your performance.
That's the group projects. Those are later. Just
yeah, exactly.
But the beauty is, you're all in it together, and then it's like it's fun at the end. It's
you have to listen to each other. Yeah. So good analogy.
Awesome. All right. That said, I think we made it through the end of today's lesson. How are y'all feeling? Thumbs up.
Lost but motivated.
Right on. That's what I like to hear. Cool. Okay.
When I hit the full stack Docker portion, I really almost wanted to just quit. I didn't feel like it was for me. That was my lowest point in the last 2 years of doing this whole thing. Was I hit Docker. It was completely different than what I had been learning software development. It's different, but it's different and it's the same. So yeah, I really wanted, so seriously, a couple other students kind of lifted me up, and I got through it, and I love Docker now. I use it every day, like every single day. I have all kinds of projects, and it makes my life so much easier.
Awesome.
Thanks, Chad.
Right on. Awesome. Okay, I think we all could use a break, so let's do that. I will set up some breakout rooms. If you need any help, just hop into the main room, ask Kendra, Chad, or I for assistance, and we'll be here in the main room to demo different things or to walk through installs together. Sound good?
So yeah, and if we're installing Docker and have to do the restart, it means we go off Zoom for a little bit. Is that what you want, or you want us to hold off on that until after class?
Yeah, let's do that. Let's do that sooner rather than later. So if you do run into issues, we can work through them together in the main room.
Okay. Yeah, and I can always call back in on my, actually I have Zoom on my phone as well, so I can return that way if my computer for any reason, which I don't see a problem.
Awesome. All right, let's take a 15 and I'll see you all back here, and breakout rooms be open.
Great, thank you.
Hey, Julius, I think you're still recording. I'm not sure if that's intentional or not.
Oh, it's definitely not intentional. Thanks for letting me know, Saul.